Okay, let's continue. So in this video, we're going to talk about indicator variables. So we see that the variable time has three values: morning, afternoon, or evening. The interesting thing is that even though we may label them as numeric numbers, but even if we do that, we cannot use it as a quantitative variable to do regression. Okay, so we probably label them as strings. Then of course we cannot use it as a quantitative variable. But even if we label them as numbers, we still cannot. So why? Why is that? Why we cannot just call them 1, 2, 3 and do a regression model? If we really do that, we will get a regression model like this. Okay? Seems to be explainable. When we add time by 1, when time increases by 1, we expect a sales increase by 6.3. And 1 here is explainable, right? Because that means from morning to afternoon or from afternoon to evening. So why? Why is this equation wrong? The answer is that if we choose different labeling, actually we will get different regression results. Previously, we labeled them as 1, 2, 3, but no one says we should do that, right? We may actually label them as 1, 2, 10 or 3, 1, 2. It has no rule for us to decide how to label that three variables. If we label them as 1, 2, 3, okay, morning, afternoon, and evening, we get around 6.3 as our coefficient, and that's not a significant variable. If we label them as 1, 2, 10, then the impact is even more smaller because the slope will just become flatter. Okay, and we can see indeed that there's no impact on time. But if we relabel them as 3, 1, 2, okay, we move this column to the left, and then we can see a downward trend, right? Downward trend, and obviously that's not making sense because we have a set of data, and if we choose different ways to label the data, the result would be different. That's weird. That's weird. So when you have some variables that you can give them numeric values, and then the result would change when you use different ways of labeling, that's obviously a qualitative variable. And that's something you cannot just use their numeric values to do regression. Okay, so let's continue. There is one thing that we need to know. When we have a qualitative variable, we cannot just use their numeric values to do regression. But if a qualitative variable is binary, then we can do something. First, we may label the values as 0 and 1, and then treat it as a quantitative variable. Actually, if we label them as 1 and 0, 1 and 2, 7 and 8, then when we treat it as quantitative and put it into a regression model, we'll be fine. As long as we label them as some numbers whose difference is not 1, then it's bad. Okay, why is that? As long as we label the two possible values as some numbers whose difference is 1, then the regression coefficient can tell us what's the impact when the value goes from one to the other one. Because in general, when we put a numerical variable into a model, that coefficient tells us when the independent variable increases by 1. When the independent variable increases by 1, what happens to the dependent variable, right? That's the regression coefficient's meaning. So if there are only two values and the difference is 1, then when the independent variable increases by 1, that just means moving from 0 to 1. Okay? And moving from 1 to 0 will have an impact which is negative, or the negation of the coefficient. So the coefficient beta hat I tells us that if the value changes from 0 to 1, we expect the dependent variable to increase by beta hat I. So this is useful. This is useful. When we have a qualitative variable with only binary values, just label them as 0 and 1, and then just treat it as a quantitative variable. So that's something we can do. Then we will need to decide what to do if we have more than 2 values. Okay, more than 2 values. In that case, we really need something called indicator variables. So let's consider a variable x with 3 possible values. Let's call them a, b, and c. The first thing to do is we need to choose a reference level. The meaning will be very clear later. But anyway, for the 3 possible values, we need to first choose one reference level. Let's say we choose A. And then we need to manually create 2 indicator variables. Let's call them xb and xc. So in any case, if you have n variables, you will choose 1 to be the reference level. And then for all the other unchosen values, for each of them, you will create an indicator variable to record 0 or 1. 1 means you label the variable as 1 if that corresponding value is really b. Or you label that value as 1 if that corresponding value is c. So what does that mean? That means we want to use xb and xc to represent x. X has 3 possible values, but xb and xc, each of them is binary. Okay, so we want to use 2 binary variables to represent x. X has 3 values. Here xb and xc each of them only have 2 values, but if we combine them, we are able to represent 3 values, right? If both values are 0, then we know it's not B, it's not C, then it must be A. And then if this is 1 and this is 0, we know the original value is B. And here we know the original value is C. So once we do that, then we can use these 2 binary variables to be our independent variables. We will not use x directly. We will use xb and xc. Then we have a valid regression model. So we will put xb and xc into our model and get something like this. Each of them will also get a coefficient. Then how may we interpret our model? The coefficient x hat b tells us what will happen if xb goes up by 1. So if xb goes up by 1, while all other variables remains the same, that means x changes from A to B, right? So let me remind you, A, B, C are possible values for x, and we have xb and xc, 0, 0, 1, 0, 0, 1. So originally we are at 0, 0. And then if xc remains the same but xb goes up by 1, that means we move from A to B, right? We move from A to B. So then the impact is captured by beta hat B. Of course, x may also change from A to C. So in that case, xb remains the same and the xc goes up by 1. The impact is measured by beta hat C. So that's the 2 things we can say. Unfortunately, when we adapt this method, we can say nothing about what's going to happen when x changes from B to C. Okay? Because if x changes from B to C, 2 values would change. And these coefficients cannot be combined in any way to tell us what's the expected impact. Okay? So when we have a qualitative variable, this is already the best thing to do. But still, there is something that we cannot explain. We can have a reference level, and we can know what's going to happen if we deviate from the reference level. But among those non-reference values, we can say nothing. So, in short, we use X to divide the data into 3 different groups, and we are asking, after removing the impacts from other variables, whether there is a significant difference between groups A and B or groups A and C. Okay, we are asking that. We have groups, and we ask whether there is a significant difference between groups, but we can only compare something with our reference value. That's the limit of a regression model. So, in general, if our variable has 5 different values, we will still choose one reference level. Let's call it P. Let's say we choose P as our reference level. Then, in this case, we need 4 indicator variables, 1 for each non-reference value. And then, the reference variable will always be 0. For the other 4, it would become 1 if that corresponding value exists for X. Okay? So, what we may answer is that is there a significant difference between P and M, P and N, P and O, and P and Q? That's something we may answer. But we can say nothing about the difference between M and N and O, or something else. Okay? So in general, if we have a variable which has k values, then we need k-1 indicator variables to represent that single variable. And then we will put all those indicator variables into our model. Okay, so that's coming back to our example. We know we have a variable called time. Time has 3 different values. So we need to first choose a reference level. Let's choose afternoon. The reason is that because A is the first letter. Okay, so we need 2 indicator variables, one for morning, one for evening. So we're going to label them in this way. The reference level is always 0, and the others have 1, 1 there. If we use time M and time E as our independent variable only, then we will get something like this. The sales quantity would be 191 minus 30 times time M minus 16 times time E, where the P values are quite small or somewhat large. So if we get this, what does that mean? There is a significant difference between morning and afternoon. The difference between morning and evening is not significant. But at least from these 2 values we know, in average, afternoon has the largest sales, and the morning is bad, time is also somewhat bad. So, if a performance is rescheduled from afternoon to morning, time M is increased by 1. So we expect the lost sales to be around 30. Okay, that's how we interpret the model. So now it's time to include everything. Let's take capacity, average price, and year all together, while we include the 2 indicator variables. Then we get a regression report like this. Oh, that's great, because all the p-values are small enough. Okay, we have a lot of stars, and we see the 5 variables. We get their coefficients and some other unuseful things. R-squared gets to 60%, even better than the previous model. R-squared adjusted is also increased. So when the number of seats we have increased by 1, we expect to generate 0.7 sales. for the average price impact, we find one interesting thing. When the price goes up, actually we have a positive impact on sales. So this may be the case that people take, for example, the ticket price as some kind of reference or signal about the performance quality, okay, or some other reasons. But we can see that there is a positive thing. So at least if we are running a theater, it is suggesting us to consider increasing the price. We can see a downward trend. So as a theater owner, we need to be worrying about this, because from year to year we are generating less and less sales. That cannot be good. For time, we find out that the afternoon is the best time to make performances. Okay. And interestingly, we find out that afternoon is the best, and then is the morning, and then is the evening. And this is opposite from the finding in the previous page. Okay, if we only have time, we find that in the morning the average sales is the lowest. Okay, but that's because we have not taken away the impact of other variables. Once we do that, we find that people actually somewhat prefer morning performances than evening performances. Okay, so we really need to consider enough variables so that our explanation or interpretations to the coefficients make sense. Okay, something to keep in mind. So, summary. When an independent variable is qualitative, then we need to introduce indicator variables. And all the indicator variables, the values would just be 0 or 1. If the variable has k possible values, then we need k minus 1 indicator variables. For the reference level, all the indicator variables will be marked as 0. For each other, exactly one indicator variable will get value 1. What we are only testing is the difference between the reference level and one another level. For each indicator variable, we can get one comparison between the reference level and someone other. We have no idea about the difference between two non-reference levels, and that means if we, for example, have variables a, b, and c, if we choose reference level to be a, then we cannot compare b and c. So if we actually want to compare b and c, then we need to change our reference level. Okay? Then we need to change our reference level and redo the regression. We're going to see what's the impact between b and c. Finally, as long as one indicator variable is significant, then when we want to keep that indicator variable, we need to keep all other indicator variables from the same qualitative variable. That makes sense, right? Because all those indicator variables all together represent one original variable. So if we want to keep one of them, we need to keep all of them so that it provides the full picture. Okay, that's indicator variable. Thank you.